അവിടെ ഇവിടെ Hello. Hello. Is it audible? Can you open it?
Yes, sir.
No, you can ask one way only, right?
It's audible.
Can I able to see the PPT?
No. You just share it again. Switch on your video.
Audible? Audible?
Good afternoon, sir. Dr. Vinoth Kumar is working as Associate Professor in School of Computer Science, Engineering and Information Systems, Vinoth Institute of Technology, India. He is serving as Adjunct Professor associated with School of Computer Science, Taylor's University, Malaysia. He has published 105 technical articles in referred journals and proceedings with H index of 29 and IN index of 65. He has built 17 domestic patents and Google Scholar for his publications. Recently, he has published 5 papers in IoT transaction journals, among that one paper published with 10.6 impact factor. Sir, I now request you to felicitate. Sir, I now request you to address the gathering.
So good evening to all. Myself, Dr. Vinoth Kumar, School of Computer Science and Information Systems, Vinoth Institute of Technology, VIT. So thank you for inviting me to discuss about the topic IoT in smart agriculture. So the table of content, I'm going to discuss about the introduction of IoT for smart agriculture, then why IoT for smart agriculture, how IoT is revolutionizing agriculture, smart agricultural system architectures with various sensors and different farming analytics and its applications. Then top 10 strategic IoT technologies and trends which we are using in research. And what are the challenges of IoT when we implement it into the agricultural systems? Then benefits of IoT in smart agriculture. So I hope everyone knows that in recent years, many of them are finding, all the researchers are finding the term IoT everywhere. We can able to hear this word IoT and IoT. What is meant by IoT? Many of you know the definition. Everyone giving their own definition. There is no standard definition for the IoT. But the simple way to define the IoT is all the things, that means objects or physical objects, can be connected into the internet. Then it will be a IoT. So in every day, 8.3 million things got connected into the internet system. This is just a survey only. Think of it. Every day, 8.3 million approximate number of physical objects are connected into the internet system. Then how many objects will be connected in a month and a year and a year? Now, the IoT systems are used and implemented in different applications, but the major contribution is the agricultural system. IoT is implemented in agricultural system. So most of the farm elements to be connected in the digital world using a sensor or actuators or any smart machines to share the real-time data on soil, climate, crops, and data. Now that there is a need to connect these objects, farming elements, into the internet system to make efficient monitoring as well as optimize the resources like the water and fertilizer, automated tasks, and improve crop yields also. We know that when we do the farming, we need to improve the crop yields. Yield is the final outcome of the farming. We need to improve the yields. So how we can improve it? So many practical challenges and problems are there when we make the farming. So in the recent years, we started to implement many IoT applications. We designed many IoT applications with the smart farming to improve the crop yields. This is one survey. It has been taken in 2017. There is a forecasting of the populations. The time of survey, 1.34 billion population for the India in 2017. The probability of forecasting for the 2050 is 1.66. The China 1.41 at the time of 2017. But the probability of 2050 will be 1.36. So we will cross the population in China at the time of 2050. Likewise, the different country projections are forecasting results are given here. So the reason for taking this analysis is when the populations are increasing, we need to increase the productivity. If the productivity is less, the population is more, we cannot balance the system. There will be a demand at the time, and we cannot survive in our life. So the population when it is increasing, we need to take some initiatives to improve the farming as well as the yield of the farming. In the smart agriculture, when we implement the IoT system, there are two challenges. One is we need to improve the green revolution. One more is technology revolution. What is the green revolution? We need to improve the crop yield without affecting the environment, without changing the climatic conditions, without disturbing the ecosystem. The projection by 2050, the double agriculture will need it. Otherwise, we cannot be able to manage it. When we implement a smart agricultural system by using the IoT, the wastage in cost and losses will be by 50%. And when we implement IoT in agriculture, lesser impact on the environment. So when we have these three parameters, we can easily apply the green revolution. Now we call it as a technology revolution. Lot of challenges are there in the smart agricultural system. The one is land degradation, maybe naturally or human can disturb the system. The land degradations are there. So nowadays, the many the land surfaces are they made it to the houses, the forest deforestation. So the land surfaces are reducing. So it will affect the ecosystem. The second is definition of water resources. So the 10 to 15 years back, there are no such kind of number of borewells in our farming. But now everyone are making the borewell to get the water for making the farming. The reason is the lack of water and the ground level of water also decrease. Then second level is water population, so water pollution. So many industries are started to pollute the water and it disturb the ecosystem. We cannot use that polluted water for the farming. The labor cost. Nowadays nobody is interested to come for the farming because they are going for the other jobs. So labor cost also increasing. The climatical changes. We cannot expect the rain in the right time. The right time we should give the water to the crops. Otherwise, we cannot expect the yield. Then decline productivity. Ultimately, it will affect the productivity. We cannot expect the maximum yield from the farming. So these are the general problems or challenges we are facing when we do the farming. In the past system, before IoT, we used the GPS tracking and the machinery applications. But now we are using the IoT. In future, we can analyze the complete data which is derived or taken from the IoT system. And we can use those data for the data insights. So this prediction-based applications we can discuss. So why IoT for agriculture? This is the biggest question. And there is a reasonable answer also is there. Why we have to use the IoT for agriculture? We know that we are expecting double of the productivity by 2025, what we are having now. So it increases when we use the IoT techniques, enhance the produce quantity and reduce cost and precision. So right quantity and right time for the water we can able to supply when we use the IoT. It's an example. So every day once we need to give the water, but we don't have that water or we don't know how to, when we have to give the water supply to the farming, to our crop field. So when we design the IoT system, automatically based on the humidity, automatically it's how to supply or pour the water. So when we use the IoT for agriculture, the technology and information we can use, and we can take some good decision at the right time and connectivity of the data also we can improve. When we use the IoT in agriculture, we can use field management, climate analysis and forecast, equipment tracking, livestock monitoring. If I have a animal or poultry, I cannot manually count the number of livestock are there. Easily I can monitor and count greenhouse farming, energy and water conservation. So these are the major domains in the IoT agricultural field. How many other parts also is there, but major parts only given here. How IoT revolution agriculture? The first one is the precision farming. That is the good thing in the IoT. When we use the precision farming, what is the precision farming? Based on the climatic condition, environmental need, we have to take some decision. Example, apply resources like water and fertilizer. When we have to give the fertilizer, and where we have to give it, we can give at the right time, right place. So it minimizes the waste and maximizes the resource efficiency. Example, we don't want to do the fertilizer at the 20th day of planting. but we are giving example. So it's best only because the plant won't take the fertilizer to grow it. So we need to know when we have to give and where we have to give, what time we have to give, all those things based on the need and demand we have to give it. Same way, we can do the water also in the precision farming. So in most of the cases it reduces the waste and maximizes the resources. Next, remote monitoring and control. Easily I can monitor the plant activity by using my smartphone. I can automate it. I am 100 kilometers far away from the farming. Easily I can control the entire thing by using the smartphone. If I want to turn on the motor, I can do it. I don't know the soil moisture. I use it IoT sensor automatically to monitor and update the data to me. My mobile phone can take the data and analyze it. If it is needed to supply the water, it can start to supply it. This is a simple smart agricultural system architecture. In the IoT system, three different layers are there. One is precision perception layer, that means how IoT system is working, example sensors, actuators. Next part is network layer. What way we are providing the internet connectivity to connect the applications, example mobile phone. So this is the common layer or the operation of the smart agriculture. Only the thing is, if you are what type of sensor you are using, what type of actuators you are using, what type of mobile app you are using, and why they are doing that only different. What only different. I'm taking one simple example, one plant I'm taking in the agricultural system. What are the way we can implement the IoT system? One is I can analyze the soil moisture of the plant. Then I can use the irrigation, smart irrigation system. Based on water nutrients, I can able to supply it. The climate analysis, climate prediction, then energy supply. Then images, I can put the CCTV camera or any other special cameras I can put in this and to I can analyze it. The other side, if you want to store the data in some other places or remote area or the cloud system, we can use it by using the agent for control. Various sensors we are using in the agricultural system. I hope many of you know the sensor names and the purposes. But the major sensors, because I cannot violate or skip this part, the major sensors we need to know it. At least 10 sensors we know it. One is the weather sensors. We know the weather sensor to monitor the weather. The second one is soil moisture and the connectivity sensor. The soil moisture sensor monitor the moisture level. Then valves also we are using. In smart valves or sophisticated devices, they control the flow of water in the irrigation system. Unlike the traditional valves we use, but it won't help to make the smart farm. This valve monitors the soil moisture. If it is regular, it will start the irrigation system. Otherwise, it will stop it. The leaf gradients also we are using. It covers the free water on the plant surface. Example, if you have the more water in the leaf gradients, what will happen in the plant surface? So it will bring rain or for the irrigation system or some fungal diseases will come. So continuously the free water on a plant surface, it will affect the plant life as well as the health. So preventing fungal diseases is very important in certain plants. Next one is soil moisture. This sensor coats and surfaces of the soil. Easily can monitor it. Then ambient and humidity temperature. This combination nowadays, all three together is coming as a one sensor. This sensor monitors the moisture and water. The soil temperature. So the seeds, especially we are using this one in the seed germination and the plant growth. radiation system are different. So it increases the crop selection, growth optimization, and resource management. The wind directions farmers can reduce chemical drift also to prevent uneven water distribution. When water level ultrasonic sensor is there, it optimizes the water by enabling the real-time monitoring and ensure the efficient management of water resources. The next one is pH sensor. We know that nowadays we are using the RO system, the normal water, pure water, have the pHs, that means potential of hydrogen.
Thank you, sir, for sharing your knowledge and brave words. Final year students, you can leave. Third year students, you have to go for your respective classrooms. You have your governance system. Okay? So tomorrow you have your session. Assemble here tomorrow morning by 9:50. 9:15.
Bonus பண்ணுங்க. Está